In this video, we're going to graph a rational function by hand. I have the steps laid out here, and then we have the function, f1, that we're going to graph. Step 1, find all the vertical asymptotes and sketch as dotted lines and then label them on the graph. Okay, well, let's look here. The vertical asymptotes come from the denominator. It's when the denominator basically equals 0, so I set it equal to 0, and I solve. Add an x to both sides. So my vertical asymptote is at x equals 3. Alright, let's go down to my graph. 1, 2, 3. Here's 3. I'm going to draw a dotted line at x equals 3 and then label it. X equals 3. Okay? That's the only vertical asymptote there is in this graph. Okay? Move on to 2. Find all horizontal or slant asymptotes and graph those. Alright, well, we see that the degree of the numerator is 0. The degree of the denominator is 1. So this is very similar to the graph 1 over x, right? So it has a horizontal asymptote at y equals 0. Right? I will put that in. Horizontal at y equals 0. So these are just aids to help in graphing the real part of the graph. Y equals 0. Alright, step 3, find the y-intercept if possible. So evaluate f of 0. Okay, I'm going to graph in the color of let's say green, so I'm going to change it to green here. So we want to find f of 0. So in my function f1, I will put 0 into it. 2 over 3 minus 0. f1, if I put 0 into it, I have 2 over 3. Alright, so that means it crosses at 2/3 on the y-axis. That is the y-intercept, right? X is 0, you're on this line. So 2/3, that's approximately right there. Okay? Next, find the X-intercepts, if any, by solving f of x equal to 0. Okay? Here's f of x again. I want to set this equal to 0. So it's 0 equals 2 over 3 minus x. Now remember, for a fraction to be equal to 0, you have to have the numerator equal to 0. In this case, I can never get it equal to 0, so that doesn't cross the x-axis. Which makes sense because there's a horizontal asymptote, it gets closer and closer. But remember how to solve something with fractions like this. If you need to solve it, this is how you do it. Multiply both sides by the LCD, right? See, both sides by the LCD. Here they cancel. Here this times 0 is 0, so 0 equals 2 is not true. So it's again showing me there is no value. And I told you that before, because for a fraction to be 0, the numerator has to be 0, right? 0 over 5 is 0, right? So numerator has to be 0. Okay, let's clean up some of this. Alright, next then, determine whether the graph will cross the horizontal or slant asymptote by solving either f of x equals the horizontal or f of x equals the slant. We have a horizontal. I want to know, does the graph cross it? I kind of already know that though, because it's on the x-axis, right? The horizontal is the x-axis and it doesn't cross it. But this is the way I would do it. The horizontal asymptote is 0. So I would let this, y, equals 0. And then 2 over 3 minus x. Again, I solve it by multiplying by 3 minus x. 3 minus x. These ones cancel, and this is 0. So 0 equals 2 again is not true. Alright, so again, it doesn't cross this line at all. So now I move on to step 6. Step 6 is plot some selected points. Choose n x value in each of these intervals, basically the right side and the left side of the vertical asymptote. Okay. Alright, well, I know it's over here, right? And it has to go towards this asymptote, and it goes towards this asymptote. You were kind of locked in here where it goes. But let's just put 1 in there to show what happens. 2 over 3 minus 1. So if I put 1 into the function, okay, this is my 1 in, I get 2 over 3 minus 1. 2 over 2 is 1. So f1, when I put a 1 in there, I get 1 out. So basically 1, 1, it's here. Right? And that makes sense because it's got to go from here to here and then up this way. It's got to go towards x equals 3. That's what an asymptote is. And it goes from here to here towards this way. Be careful though, I kind of graphed a lot. There we go. Don't go over the red line because it doesn't. Okay, that's the left side. Now let's look at the right side. Oh, let's choose this number right there. 1, 2, 3, 4. See, 4. I'm expecting 4 to be probably down here, so let's put it in there. So if I put 4 into my function, 2 over 3 minus 4. 2 over negative 1, negative 2. So when I put 4 into the function, I get negative 2 out. 1, 2. I get right there. Right? Which makes sense. Alright, then it has to go down towards here and over towards there. Again, put in some more points if you don't believe me or you're not quite sure. Put in 5, you'll see that it comes up here a little bit. And if you put in closer, like a fraction, which is a little tough, you'll see that it gets closer to here. So remember, you're just sketching it, and so you got a good idea now what it looks like. That's what the graph looks like. Let's look at a more professional graph here. Here we see the graph. Approaching the vertical asymptote, approaching the horizontal, approaching the vertical and the horizontal. You see the points that I graphed, 4, negative 2, 1, 1, and 0, 2/3. This 1 indicates the tick marks, okay? That 1 does not indicate it's right there. So 0, 2/3 is that point. And there's the same graph that I did, obviously a little neater, but that's how you graph a rational function.